Okay, I'm having a look at some revision questions for 11 Maths Methods, Unit 1, looking at Chapter 6. These are from the chapter tests. So we've got, for the function with the rule f of x equals 2x plus 5, determine the following. So when we see f of 2, wherever we see an x in our function, we're going to put a 2, and then we're going to put a 3 for the other part. So for f of 2, f of 3, we're going to do 2 outside of 2 plus 5, and then we're going to add to that 2 outside of 3 plus 5. So we're just putting the values of x into that function there. So 2 times 2 is 4 plus 5 is 9, and 2 times 3 is 6 plus 5 is 11, and then that will just be equal to 20. For the next one, we're putting in -1 and 1. So we've got f of -1 plus f of 1. I'm just going to switch pens. So then we've got our 2 times -1 plus 5, and we're adding to that 2 times 1 plus 5. So 2 times -1 is -2 plus 5 is 3, and we're adding that to that 2 times 1 is 2 plus 5 is 7. So our answer for that will be 10. The next one, we're just putting in a and 2a. So first we're going, -2a, sorry. So first we're just going to put in the a. So where we see an x, we're just going to write a. So we'll have 2a plus 5. And then we're going to put in -2a where we see the x. So we've got 2 lots of -2a plus 5. And we're adding those two together. So then we're just going to simplify that. So we've got 2a plus 5, take 4a plus 5. So overall that will be -2a plus 10. Then the last one has f of a plus 2 and f of a minus 2. So I'll bring that up here. So wherever we see an x, we're going to put an a plus 2, and then the second time we're going to put an a minus 2. So we've got 2 lots of a plus 2 plus 5, and then we've got 2 lots of a take away 2 plus 5. So now we're just going to simplify that. So we get 2a plus 4 plus 5 plus 2a take 4 plus 5. So we've got 2a plus 2a is 4a. The plus 4 and the minus 4 will cancel out, and we'll have plus 10 as our answer. The next one we have looks at the range of a function. So what we can do is we can have a look at our calculator if we want. It is a linear function, so we know we could just sub the values in. So I'm going to pop it in so you can see we've got 5 take away x, and you can see that linear function there. We're only going between -2 and 7, so we could restrict the domain for that and put in our what is it, between -2 and that is, and I think this should work, I haven't done it. I need to change that one, sorry. 7, and I think that should work. No, it hasn't restricted it for me, so I'm gonna, I think I needed to put my curly brackets in for that. No, so I'm gonna leave that one and just come back to that and just look at the -2, the 5 take away x. So when I'm looking at that, I know that my -2 is going to be my highest value. So when I sub into that -2, I'm going to get 7, and when I sub in the 7, I get -2. So I know that my range then goes from -2 to 7. I know that the box bracket will go with the 7 because that's what I subbed in with the 2, and then my curve bracket will go with the -2. For number 20, we've got the maximal domain of the function with the rule f of x is the square root of 5x minus 7. So popping that in our calculator, we can have a look at that 1. Now we can see that we get stopped here with our values because we can't go any further, because if our x is, if we get a negative number inside that square root sign, obviously we can't work it out. So if our x is any larger than or smaller than a certain number, it won't be able to work it out. So we've got 5x minus 7. We don't want that. We want to find out when that's equal to 0. So bring the 7 over, and then that will give us our 5x, and our x would equal 7 on 5. When it is less than that, that is when you won't get an answer for it. So we could change our window to go a lot higher, and you'll see that graph keeps going further. But if the x is less than 7 on 5, then you won't be able to graph it, which means your x has to be greater than, less than, so we need it to be greater than 7 over 5 to be able to graph that. So our domain would then be 7 on 5, comma, infinity, because it can go up to infinity, and we can include the 7 on 5. That will give us 0, but any less than that, so we use our box brackets for that one. The last one is a piecewise function. So when we pop that in our calculator, we can press our math button, arrow up to piecewise. We have 3 pieces, so we're gonna pop that in, and that brings that up on our screen for us. So we can now do negative x plus 6 in the first one, we can put x plus 2 in the second one, and we can do 2x plus 1 in the third one. And then we've got when x is, and we're going to put that less than or equal to 0, so that second math one goes in there, and then we've got between 0 and 3, and then we've got when x is greater than or equal to 3. And so that will then graph that function in those pieces for us. So it's got those 3 pieces there. Now our range, we've got, obviously we can find our smallest number here. So that's in that second one when we sub in 0. So x plus 2 is, 0 plus 2 is 2. So that's our lowest number there. And then we've got our highest number will be this one over here, which is our third function. So when, so if we, because it goes, x is continuing to go up, if we extend that x to say 100, we'll see that that keeps going up. So that will be to infinity. We just have to check if there are any discontinuities there. So if we sub in our, so we're trying to see if there's anything in between that 2. So there we've got the negative x plus 6 when x is less than 0. Obviously that's a way that's going up, and it gets to that point there. We're just looking for this gap here, if there's any little gaps there. 2x plus 1, when we sub in our 3, we're going to get 6 plus 1 is 7. So we're kind of looking at what are the heights as those gaps come. So we may have this little gap here in the range, and so we might have to do it in pieces. So we've kind of got, for the first one, its range is obviously going to be from infinity to, and when we put in the 0, we will get 0 plus 6 is 6. So we've got that. And then for the next one, between 0 and 3, so 0 plus 2 is 2. And then 3 plus 2 is 5. And then the third one, when we put that in, 6 plus 1 was 7. And when it is greater than, or 7 was, and we know that it's going up to infinity there. So we have those 3, so we do have those gaps in there, so we can just say it is that overlap between those 3 different functions there. Or we could put the union of them as well, and that would include that. So actually should put our union signs there to show that we're using those 3 sets of values there.